TypeScript just became the #1 programming language on GitHub. According to the Octoverse 2025 report, it overtook both Python and JavaScript with over 2.6 million active contributors. This isn't an accident. Next.js, SvelteKit, Astro, Quick, all the major frameworks now scaffold projects in TypeScript by default. The industry has decided. Types are the future. But here's the problem. TypeScript only catches bugs when you use it correctly, and most developers don't. This video covers 7 patterns that defeat the purpose of TypeScript. Each one silently turns off the compiler's ability to help you. You write TypeScript, but you get JavaScript-level safety. By the end, you'll know exactly which patterns to avoid and what to use instead. Let's start with the most common one. Pattern number 1, using any everywhere. Watch what happens when we type this API response as any. We fetch some data, type it as any, and access data.user_profiler.name. Look at the error panel. 0 errors. Now watch this. I'll add an obvious typo. Data.user.profile.name. Still 0 errors. TypeScript has completely given up. Any typo, any wrong property, any mistake, it all compiles. Now let's try unknown instead of any. Same code, but typed as unknown. Now try to access data.user. TypeScript blocks it. Data is of type unknown. You must validate before accessing. Finally, proper types. With a user interface defined, TypeScript knows exactly what exists. The typo? Caught immediately. Property user does not exist. That's the difference between code that compiles and crashes and code that catches bugs before they ship. Pattern number 2, type assertions over type guards. Here's code that loads a user from local storage. See that as user at the end? That's you telling TypeScript, trust me, this is definitely a user. But is it? The data might be null, the JSON might be malformed, the shape might be completely wrong. TypeScript won't check any of that. It just believes you. 0 errors. But this crashes the moment local storage has bad data. Now watch the safe way. This isUser function is a type guard. It checks the actual runtime value. Does it have an ID? Is it a string? Does it have email? TypeScript understands this function narrows the type. Inside the if block, we know it's a real user. Now we have both compile time and runtime safety. Use as only when you genuinely know more than the compiler. External data, APIs, local storage, URL params, always needs runtime validation. Pattern number 3, ignoring null checks. Tony Hoare, who invented null references in 1965, later called it his billion-dollar mistake. He said it led to innumerable errors, vulnerabilities, and system crashes. Let's see why TypeScript developers still make this mistake. This function findUser returns user or undefined. That or undefined is important. It means the function might not find what you're looking for. Now, watch what happens. We call findUser, then immediately access user.email. Look at the error panel. Object is possibly undefined. TypeScript caught it. But here's the catch. This only works with strict mode enabled. Many older codebases have strict mode off. Without it, this compiles perfectly and crashes in production. Some developers discover optional chaining and think it solves everything. User.email. The question mark says, if user exists, get email, otherwise return undefined. No crash, problem solved, right? Not quite. Look at the type of email now. It's string or undefined. You haven't eliminated the problem, you've pushed it downstream. Eventually, something expects a string and you're back to the same bug. The right approach is type narrowing. A simple if check, if user exists. Inside this block, TypeScript performs what's called control flow analysis. It knows that if we got past the if check, user cannot be undefined. It must be user. Now look at user.email. The type is string, not string or undefined, just string. Same with user.profile.name. TypeScript has narrowed the type based on our runtime check. This is the power of TypeScript's type system. It tracks what's possible at each point in your code. But it only works if you enable strict mode. Yes, you'll have errors to fix. Those errors are bugs waiting to happen in production. Pattern number 4, wrong generic constraints, or more often, no constraints at all. Generics are one of TypeScript's most powerful features. They let you write functions that work with multiple types while maintaining type safety. But many developers misuse them. Here's a generic function that finds items by ID. The angle bracket t is a type parameter. It's a placeholder that gets filled in when you call the function. The problem? T could be literally anything. A user object, a string, a number, undefined. We try to access item.id, but TypeScript can't guarantee that ID exists on whatever t turns out to be. Look at the error. Property ID does not exist on type T. TypeScript is right to complain. Some developers fix this by adding as any. Now look at the error panel. 0 errors. It compiles. But watch what happens when we use it. Find ID with an array of numbers. Bounded ID with an array of strings. Both compile. Both are completely wrong. Numbers don't have an ID property. Strings don't either. You haven't fixed the problem. You've silenced the compiler with extra steps. The right approach is to constrain the generic. T extends has ID. This syntax means T can be any type, but it must have at least the properties defined in has ID. In this case, an ID that's a string. Now TypeScript knows that whatever T is, it will have an ID property. We can safely access item.id. Try passing an array of numbers now. Look at the error panel. Type number does not satisfy constraint has ID. That's exactly what we want. The constraint is the whole point of using generics. Without constraints, you might as well use any. With constraints, you get flexibility and type safety. Pattern number 5, enum pitfalls, specifically numeric enums. Enums appear to be simple. You define a set of named constants. Status can be pending, active, or inactive. That's it. Here's a simple status enum. By default, TypeScript assigns numbers. Pending is 0, active is 1, inactive is 2. A function that takes status. Let's test it. Set status, status active works. Set status 1 also works since active equals 1. Now watch this. Set status 999. Look at the error panel. 0 errors. TypeScript accepts any number for a numeric enum. 999, -50, 3.14, it doesn't matter. This is intentional TypeScript behavior designed for bitwise flag operations, but it surprises most developers. String enums are stricter. Now each value is an explicit string. Pending, active, inactive. Try set status, active. Look at the error panel. Error. Argument of type active is not assignable to parameter of type status. You must use status active, the enum member, not the raw string value. This is safer, but verbose. You're constantly writing status active instead of just active. The cleanest approach for most cases is union types. Type status equals pending, or active, or inactive. No enum keyword at all. Now set status, active, works directly. The string literal is the type. Try set status, invalid. Look at the error panel. Error. Invalid is not assignable to type status. Exactly what we want. Union types have other advantages too. No runtime code is generated. Enums compile to JavaScript objects that exist at runtime. Union types disappear completely. This means better tree shaking and smaller bundles. Use numeric enums only for bitwise flags. Use union types for everything else. Pattern number 6, interface versus type confusion. This is one of the most common questions TypeScript developers ask. When should I use interface? When should I use type? Let's clear it up. First, let's see what interfaces can't do. Trying to create a union type with interface. Interface status equals pending or active. Look at the error. This syntax is completely wrong. Interfaces use a different structure entirely. They don't use the equals sign, and they can only describe object shapes. Interface for a primitive alias like string? Error. Interface for a tuple? Error. Interface for a mapped type? Error. Here's the simple rule. Use type for unions, primitives, tuples, and any computed or conditional types. Type status equals pending or active or inactive. This is a union of string literals. Type undistring. This is a type alias for a primitive. Type coordinate equals a tuple of 2 numbers. Type result is a discriminated union with success and failure cases. All of these are impossible with interfaces. Use interface for object shapes, especially when you might extend them later. Interface user with ID and email properties. Interface admin extends user, adding a permissions array. This extension pattern is clean and readable. Interfaces have one unique feature, declaration merging. If you declare the same interface twice, TypeScript combines them. This is useful for extending third-party types, but it can also cause accidental bugs. Types are more flexible for complex compositions. Interfaces are slightly better for object shapes that might be extended. Honestly, for most codebases, pick one as your default and be consistent. The consistency matters more than which one you choose. Many teams use type for everything. Many use interface for objects and type for everything else. Both approaches work. Pattern number 7, not using strict mode. This is the biggest one because it affects everything else. Strict mode isn't one setting. It's a collection of compiler flags that make TypeScript actually strict. Without it, TypeScript is surprisingly permissive. Here's a function with strict mode off. Function process takes data. No type annotation at all. We access data.anything, datafoo.bar.bos, random properties that may or may not exist. Look at the error panel. One error, parameter data implicitly has an any type. But here's the thing, the TypeScript Playground uses strict mode by default. That's why you see this error. In a real project with strict false in tsconfig.json, this compiles without any errors. Data becomes implicit any. TypeScript stops checking entirely. Process null. Compiles. Crashes at runtime. This is why strict mode matters. Without it, you're not getting TypeScript's protection. You're getting JavaScript with extra syntax. Now the same function with strict mode enabled. We're forced to add types, an input interface with optional nested properties. The function signature explicitly declares what it accepts and returns. Inside, we use optional chaining to safely navigate the nested structure. We handle the case where the path doesn't exist. We throw a meaningful error. Now try process null. Look at the error panel. Argument of type null is not assignable to parameter of type input. TypeScript caught it at compile time. Strict mode enables several important flags. Strict null checks makes null and undefined their own types. No implicit any requires explicit types when TypeScript can't infer them. Strict function types catches subtle bugs in function parameter types. If you're starting a new project, enable strict mode from day one. It's much easier than adding it later. Existing project? Enable one flag at a time. Start with no implicit any. Fix those errors. Then enable strict null checks. Fix those errors. The errors you fix aren't busy work. They're bugs that exist in your code right now, waiting to crash in production. Let's recap the 7 patterns that defeat TypeScript. Number 1, using any everywhere. Any turns off type checking completely. Replace it with proper types. If you don't know the shape yet, use unknown and validate at runtime. Number 2, type assertions over type guards. The as keyword tells TypeScript to trust you. For external data, don't ask for trust. Prove it with a type guard. Number 3, ignoring null checks. Optional chaining prevents crashes but doesn't eliminate undefined. Use control flow to narrow your types. Number 4, wrong generic constraints. If your generic function accesses properties, constrain the generic. T extends has ID. Otherwise, you're just using any with extra steps. Number 5, numeric enum pitfalls. Numeric enums accept any number. Use union types instead. They're stricter and generate no runtime code. Number 6, interface versus type confusion. Use type for unions, primitives, and tuples. Use interface for object shapes. Pick one as your default and stay consistent. Number 7, not using strict mode. This is the foundation. Without it, the other rules barely matter. TypeScript without strict mode is JavaScript with extra syntax. Your action items this week. Open tsconfig.json. Set strict to true. Then search your codebase for :any and as. Each one is a location where TypeScript has given up trying to help you. TypeScript catches bugs, but only when you let it. These changes take effort up front. The production crashes they prevent make it worth it.